everyone. My name is Jo, and welcome to today's webinar on rethinking instrument integration for lab informatics. A couple of housekeeping items before we get started. Some of you in error may have received emails asking you to register after you already registered. We do apologize, and this has been resolved. During the webinar, if you have any questions, please put them in the Q&A section, and we will get to them at the end of the presentation. This webinar is being recorded, and we will make it available to everyone after the event. Now, without further ado, I would like to introduce today's presenter, Dan DeAlmeida, Head of Product Management here at Cytera. Dan, over to you.
Thanks, Jo. Good morning, good afternoon, everyone. Thanks for attending our presentation here. I'm going to go through a quick deck and talk about rethinking instrument integration, how we see it here at Cytera. So just give me one moment to get that up and running. All right. Apologies. So I'm going to go through this quick agenda here, where we'll talk a little bit about digital transformation, some of the goals of labs, some of the common reasons for failures in these implementation efforts, how we see the current state of the analytical lab, DLX, and Cytera's scientific integration platform. And then we'll have time for Q&A at the end. As Jo said, please put any of your questions into the chat, or actually the Q&A, not the chat, two different things. And then we will answer those at the end of the session. So if we think of digital transformation, just about every business in every industry has some type of digital transformation program or project going on in play. But when we think about it from the lab, we're typically looking at the advancement of certain technologies, and we think of ELNs, LIMS systems, CDSs. We're looking at EBRs and really looking for ways to improve the process controls, right, to reduce that variability or improve efficiency. And then the past few years, there's obviously been a real push into IoT-based monitoring, so remote monitoring and viewing of lab operations, and then cloud-based storage for a lot of the data analytics to improve. And then recently, obviously, more and more, you're seeing more push into the AI space and machine learning for all of that data analysis. When we talk to our customers, you can see that they have very similar needs in different spaces when it comes to digital transformation. So the business owners are looking to improve integrity, do more, obviously improve agility, increase revenue. The lab IT and digital science teams are looking for very similar things. They might call it a little differently, but you can see the maximize ROI, improve agility, efficiency, and reduce costs. But they're looking at it from different perspectives. The business leadership is really looking at it to eliminate errors and cut those costs, add new technologies quicker, really reduce the time to release. Now, when you look at the digital science teams and the lab IT, they might be thinking of it more of reduce the impact to the IT investments and moving to what's called a composable architecture. I'll get into that in a moment. And then, again, reducing the cost to really simplify the tech stack. That's how they're going to reduce the costs, is making this much simpler and then break free from the point-to-point integrations. For anyone who's interested in composable architecture, there is a great article out there. The link is at the bottom, and we could share that out after the presentation. We're also doing a talk at the Lab of the Future USA in March. So our CTO, Jeff Gerhardt, will be talking about extending a composable IT architecture into the laboratories. So if you're around in Boston, feel free to join us at the event and listen in on that talk. So some of the common reasons for implementation failures. Again, this is an article taken from Asterix, and we can share that out with you. When we think of implementation projects, there's a few items here that we can look at what makes it successful. So from a delivery timeline, we want to be on time. We want to make sure that we meet all the user requirements, we provide business value, and really it's around user adoption. As a product manager, user adoption is a huge goal in our space. But when you look at implementation failures, and this article was taken directly as LIMS implementation failures, but we can truly extend this to any type of implementation project. There's challenges around the strategic planning. That lack of planning right at the beginning slows down that implementation. Not taking the time to understand those user needs, rushing to implement. So this is a big one, rushing to implement, without optimizing. The opportunity to change during these projects is huge. So having the ability to optimize the process, not just convert it from paper to digital, but really taking a look at it and saying, are we doing it the best ways? And can we do things better with the support of this new technology that we're implementing? And then, that personal resource challenge. So it goes back to that high level of user adoption. If it's really not that easy to use, you're going to have challenges getting your users to accept it and move forward across that project. Now, the way we see the current lab state is you have a bunch of different informatics systems, maybe some different devices, a data lake, maybe a couple of data lakes, a couple of ELNs. And traditionally, how these connections were made from an informatics system into an instrument was you would have a point-to-point solution. So you'd go to your LIMS and you would have someone develop a connection, or that LIMS might inherently have connectivity to a balance. But if you really want to take that same connectivity or different connectivity from your ELN into a different system, well, now you'd have to build this point-to-point integration. So very quickly, if you expand this out, you can see that you get this very overcomplicated point-to-point solution when it comes to your laboratory infrastructure. Not to mention redundancy and multiple points of failure for the same type of device. So again, if you're looking at cost, there's probably cost involved in developing these redundant connections from a balance to your ELN, to your LIMS, to your MES. Maybe a balance might not make sense there, but as you go through all of these, you can see how there's a lot of duplication effort in project. Now, if you think of changing that perspective a little bit and introducing Cytara DLX, what we're providing is more of an infrastructure layer here that allows for peer-to-peer automation. So that means that once you build a connection to one of these systems or devices, then that connection is then available to the other connections on our infrastructure. And so as you're going through and implementing and expanding out during the project, you can see very easily that the ability to transfer this data along the infrastructure is really expanded. So again, once you implement a connectivity to a balance or a CDS system, then your LIMS, your ELN, all of your different systems have access to the data on that platform. So connectivity is a huge part of this. So the first step is to connect, right? We can integrate all of your lab ecosystem when you start looking at benchtop devices, instrument applications, cloud-based software. But the second part is really around automating it. So now that you've collected it, you really want to power your workflows in there. You want to build a workflow that works for your environment and your application. So if we take a look at a very basic workflow, you can think of an ELN or LIMS triggering an event, and that event has some user input that it needs, and then we do some data transformation. There's a CDS involved, and then you want to notify the users on the event. So again, our system can allow the trigger of a workflow to happen from an external system. So an ELN, a LIMS could be even time triggered or user-based triggered by them pushing a button. We have the capability to provide user input forms. Obviously, an autonomous workflow would be ideal here, so you wouldn't have to have decisions made along the way, but we understand that sometimes you do need to interact with the system, so we can provide that user input form. And the ideal thing about it is we can do it as part of most informatics systems and provide that. So there's a seamless transition along the way. This data transformation step is really important when you're thinking about the ability to apply standards. So if you look at allotrope or animal, or even you're looking to put this into multiple locations at the same point, it's really a great way to take that data and format it the way you need to for your data lake. Pass the sample set information to chromatography data system, multiple options there, and then really notify that user. And so as you're going through this workflow, the goal of Cytara and DLX is actually to make this very simple. So we talked about those user requirements and the user adoption. And the benefit of our system is you will not have to learn a new system. If our technology is deployed correctly at your site, your end users, your scientists along the way won't even know we exist, right? It'll just be part of their workflow. So again, if you look at this workflow here, the user would be in ELN or LIMS. They would trigger something along the way. That form would be rendered and displayed to them. They'd interact with it, and then they'd move along the way. And most of the rest of it would be back-end architecture that would allow them to have this almost autonomous integration that helps them throughout this workflow. And so if we take a comparison of DLX to a typical LIMS, and again, this could be probably associated with either LIMS or ELN or some other system that you're integrating with it. So DLX is really the peer-to-peer solution. It's complementary to everything. We are being very vendor neutral, which is not typically what most of these vendors are doing. Obviously, they have their proprietary needs, but our intent is to connect to all the ecosystem that's out in the lab today. Our goal is also to connect to everything we can. So the more connectivity we have, the more useful we are to providing this technology to scientists and laboratories across the world. Again, going to focus back on that. There's no other application for your scientists to learn, right? It's a very important part. The only people who should be logging into DLX from our perspective would be IT folks or lab managers that are really configuring the system to be used throughout their ecosystem. And so if we think of what we're trying to provide here, Cytara is providing a scientific integration platform. So DLX is the product that we use along the way. But SIP is really the first iPaaS for science. So when you think of an iPaaS solution, which is an integration platform as a service, you think of systems like MuleSoft or Boomi, but those are very general purpose related tools. Ours is delivered directly for science, so we have an intimate knowledge of the instrumentation and the ecosystem that's in there, the applications, the informatics. And so with the ability of the automation system that I just showed you, with an orchestration layer that we have that peer-to-peer connectivity for true data mobility, and really this out-of-the-box functionality. Our goal is to deliver these connectors in an out-of-the-box way. So these are not custom configurations that we do. We have a library of connectors we can already release and connect to many things. And if you go to our website, I believe there's a list of all our connected endpoints, if you will. And if we take this and look at it from a visual perspective, again, thinking about DLX as the product, and we are connecting to on-prem devices, instruments, applications. You can see at the bottom row, what can be serial device, file-based, cloud-based. It doesn't really make a difference. And then we look at these lab informatics systems. We can connect to the typical suite of software like Box or Office 365, but then we can also connect to LIMS, ELN systems along the way. And we're partnering with a lot of these companies to really build these connectors. Now you take all of these connected endpoints and you throw it through our data orchestration layer, and that really provides customers the ability to choose where they want to put this data. So you could have a data lake, as we mentioned. You could have standardized formats, either allotrope or animal, or again, whatever fits your needs. Maybe you have a proprietary one on your premises. And then move that data along into data analytics systems to allow you to view the data and monitor it as you want to. So if we take a typical use case that we're looking at, this was a biologics manufacturing case study that we did with one of our customers. What they were looking to do is really reduce the cycle time and save on money. Obviously, it's a pretty common goal out there. So 3 simple steps in this workflow the LES requests the samples, the flow cytometer performs the analysis, and then the sample results are pushed into LIMS. So if we look at the challenges that they were having, that they really want to solve, it was really around manual transcriptions. Now, this is a pretty high number. There were 500 manual transcriptions per week at one site. So that equated to about 20 hours of analysis time. Now, one way to solve this is you hire more analysts, right? And then your cost goes up, but it's not a very scalable solution here. So with the adoption of Cytara DLX, we really reduced and practically eliminated all of the manual transcriptions of sample results. Obviously, with the automation along the way, the transcription errors are completely eliminated. So once you have validated that system, then you can be ensured that the transcription errors are eliminated. Now, if we think of that in time and cost of savings and analyst labor rate, here's some quick math. The cost savings were about $100,000 per year per site. And it's a 20-hour reduction. So that allows the scientists to really focus on what we're looking to get them to focus on, which is science, and do more value add work along the way. So again, as we're talking about the connectors and the connectivity that we have a huge partner network. Our goal is actually to work with partners to develop these connectors. And that could come from a couple of different perspectives, but what we want to do is make sure that as the systems in the industry are updated, that we are using the latest technology. We want to make sure that we're testing it with these partners. And so on a daily basis, we review our list of connectors. We're always expanding this. And then occasionally we will meet with partners to ensure along the way that we have met their needs and met the requirements of what they would like to have in our connectors and deliver that to the customers. So with that, I'd like to thank everyone for joining us. Again, this was meant to be just a quick demo. If anyone is interested in seeing a very precise demo or a specific demo for themselves and go through the software, please reach out to us and we will set that up for you.